Hello and welcome to another episode of Tilly's in a Bottle. My name's Gabriel. The locking handles on the slow speed grinder are one of the elements of the machine's design that I put a lot of thought and time into. In this video I'm going to show highlights from how these parts came about, from their concept to their final form. They're made of mild steel, and the curved features on them were turned by hand on the lathe. Yes, I'm doubling down on copying the Metal Tips and Tricks channel in this project. Thanks again, Dale. These small knurled knobs constrain the table when setting the distance from the grinding disc, and these larger knobs serve the double duty of locking the table's tilt and height. And from the beginning, I knew that I wanted these to look like cabinet pulls, but I don't have the whole concept yet. So I'm going to go out looking for a little bit of help in the design of it, the appearance of it, and I know exactly where I'm going to find that. In this old Corbin catalog. I don't know exactly how old this is, but there are some clues, I suppose, to the age. There's the Empire State Building, so this is, I expect, from the 30s or 40s. Somewhere in this book I see an address. Yeah, here it is. P.F. Corbin, 323 West Randolph Street, and there's no zip code, so this must be older than the 1950s. And my goodness, did Corbin make a lot of stuff back then. Just all manner of builder's hardware, certainly locks and handles. Transom hardware, these windows that go above doors, you know, and electric strikes, these kind of this hardware for French doors, Cremoni bolts, hinges, door closers. Look at these look at these floor checks by Corbin. Now that's interesting. And every part available for the floor check. Anyway, I know where I'm going to find what I'm looking for in this book, and that is in the section where we have our cabinet pulls, right? Drawer knobs are calling them here. Kind of like this, where we have this large inside radius leading to a large diameter, and then a smaller diameter right on the end, just like, I mean, all of these cabinet pulls are like that. But something like this. I took a trip to Italy and Spain earlier this year, and I saw that same kind of cabinet pull on this piece of door hardware that you use to secure the inactive leaf of a pair of double doors. Clearly this is the classic design. We're doing some hand turning of metal on the lathe, and my ordinary chisel is 1/4 inch, and it's doing okay, but I would like something a little bit bigger for some little bit heavier turning as well. So we're going to make a new one, and I'm going to show you how I do it. This is a piece of W1 water hardening drill rod, and we're just about done sawing it off. It's a 4-inch piece, and we're going to go over and grind this on the bench grinder, and then bring it back and heat treat it. Okay, let's see where we are. Okay, it's lost its magnetism, so it's ready to quench. It's now at the transformation stage. Alright. So it's fully hard now. We're going to polish it off a little bit and then temper it. You need to polish it first so that we can see the color before we know we're done tempering. Good. And I'll let it cool off by itself. At this point I can get the handle on. And it's back to the diamond stone. I think I've done all I can on the diamond stone, and now I'm going to move over to this, I believe this is a black Arkansas stone. The hand turning is about complete on the first knob, and this part of it is going to be knurled, and I'm waiting for a straight knurling roll to come. So until I get the knurling complete, I'm not going to cut off this big 7/8 boss that is how I'm holding this in an ER40 collet, because this diameter is too large for ER40 collets. This one now is ready to turn, now that I've figured out what I'm going to do and how to do it. The first thing I want to do is take off as much material from the stock as I can, because it doesn't all need to be turned by hand. And the best way to do that is with a form tool. A grooving tool will do really well. And I am working to a drawing a little bit. This is a scale drawing of what I want the handle to look like. And the way I'm going to go about forming off the excess material first is I'm going to set these firm joint calipers to whatever the largest section in one of these little squares on the graph paper is. And I'll remove that much, and that ought to be enough that turning this by hand won't be all too much work. Okay. Having roughed out the general sort of shape of the part, we can get on to hand turning. Here's the chisel, hand turning tool for roughing out really, and I'm going to get the general shape of this larger curve accomplished with this guy. And it's a lot like wood turning, I suppose. I've never done wood turning, but you don't go right in the middle of it, you go on top. I'll do a little bit of this without oil, so you can just kind of see what the chip load is like. This is about done. I should mention definitely that I don't know what I'm doing. We're getting results, but this is definitely new to me. Let's see if this helps me. Oh yeah. All right, yeah. I just learned that right here, right now. Yeah, you gotta have the the tool rest here. Looks like we still want to be on top of whatever raised feature we have here while we're gouging in. There's the last operation on this part finished, and that's to make a straight knurl right where you would grab it. And this is how we did it. We've got a dividing head at the back turning the back of the drawbar, and after every half turn of the dividing head, this 60-degree threading tool will shape off a little knurl about 10 thousandths deep. And I don't think you can get a knurler that will do this wide of a knurl or this deep of a knurl. Am I crazy? Maybe. Am I wasting time? Definitely. But I like how that first one came out, and I'm going to like how this one will come out too. That's the story of these parts. Usually, knurled knobs don't allow you to get an adequate amount of torque when tightening something, but usually knurled knobs are not this large. You can get a decent clamp with these large handles without really reefing down on them. The taple's transverse movement does not need as strong of a clamping force, so these are just fine being smaller. It was a lot of fun turning this stuff by hand, and it really showed me that turning curved shapes on the lathe can be easy and not require special attachments that you don't already have. After all, before the lathe had a cross slide, this was the only game in town if you wanted to turn metal. Since learning how to do this, I've made some other projects that involve hand turning. You can look out for some of that in my next video. I'll catch you later.